Hello, everyone, and welcome to today's Cloud Native Live, where we're going to dive into some very cool code behind the Cloud Native scenes. My name is Courtney Nickerson. I'm a CNCF ambassador and the head of community for Nirmata, the creators of the Kyverno project, and I'll be your host today. I'm here with my colleagues Shreyas and Mayur. They're going to be talking to us about their way of bringing Agentic AI to cloud native using Kagent and Kyverno. It's a very exciting stream for us today. Just as a reminder, every week we bring a new set of presenters to showcase how to work with cloud native technologies. So also I need to remind everyone that this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct. So please do not add anything to the chat or questions that would be in violation of our code of conduct. Basically, just be really respectful and kind to the participants as well as our presenters. And definitely throw your questions into the chat. Today's going to be very exciting. AI is all the rage. And so with that, I'm going to pass it off to Mayur and Shreyas to introduce themselves and get started.
Thank you, Courtney. Yeah, let me share my screen and then we can get started. Give me a second. Cool. Do you see my screen?
There it is.
Perfect. So yeah, hi everyone. My name is Mayur Kotumraju. I'm a solutions architect at Nirmata. And today I'm joined with Shreyas Motrala, who is the primary author of the Kyverno MCP server. And together we will show you how we're using Kyverno and Agentic AI to change the way Kubernetes governance works. So here's the plan for today. We'll start with the day-to-day reality of running Kubernetes in 2025 and why so many teams feel like they're babysitting clusters. Then we'll look into the Kyverno, the policy engine that's already solving part of the problem. And then from there, we'll introduce K-Agent and the model context protocol as that AI layer that accelerates governance. So I'll walk you through some live demos and then hand it over to Shreyas for a deeper dive look into the Kyverno MCP server. And then we'll wrap it up for any questions and how one can get involved. So that's the quick agenda for today. I know there's a lot to get covered, so I'm going to get straight into it. And feel free to ask any questions as I walk through this deep dive. So before we get into the tools, features, and demos, let's actually take a step back and talk about the reality of running Kubernetes clusters today. Even with all the great tooling we have, many teams, including some of you in this live stream today, still spend a lot of time chasing alerts, fixing repetitive issues, and writing the same policies over and over again. I call this babysitting your clusters. And now there's a new twist, right? With AI generating infrastructure as code as at machine speed, this this is like exciting for delivery and velocity, but it also means that changes are hitting clusters way faster than humans can review it. So with that strong governance, we risk a lot of issues such as config errors, insecure defaults, and most importantly, compliance gaps slipping into production before anyone even notices this, right? So Kubernetes should run smoothly once we set up the right guardrails, but in reality, the babysitting never stops. So policy guardrails are no longer optional. They're like the safety net that drives AI acceleration in a predictable operation. So the real challenge isn't just enforcing the policies, it's like scaling policy creation, explanation, remediation, and to keep up with the pace we're seeing today. So here's the good news. We already have a Kubernetes policy enforcement engine, Kyverno. So what I want to do is take a closer look at what it does well and where we still are left with some of these challenges. So I know some of you have already, part of the audience here today already knows what Kyverno is, but I do want to quickly spend a minute to set the stage and talk about Kyverno at a high level so that everyone is aware of what Kyverno is, and, and then we can go into the deep dive. So Kyverno literally means to govern in Greek, and that's exactly what it's designed to do, to govern Kubernetes resources. So it is a CNCF incubating project, as you all know. So it's well established, there's a mature and growing community around it. So at its core, it is a Kubernetes admission controller. So it intercepts requests at the API server and applies those rules before their applies those rules and then persists it to etcd. So it's purpose built for Kubernetes. So you don't need to learn a new language like Rego. All these policies are written in YAML, the same format that most of you are using today for Kubernetes management files, right? Most importantly, right now, Kyverno is the most popular policy engine by GitHub stars. I've put a quick graphic here to show you the star count, and you can see it's growing exponentially in terms of the GitHub stars. And it has the largest policy library of any policy engine, covering everything from security hardening to multi-tenancy best practices. So this is the go-to choice for most teams looking to enforce governance at scale without that steep learning curve. So I wanted to take a moment to also show you some of its capabilities. So Kyverno falls into two categories, right? The policy types and the supporting features. So the policy types are how we directly control the resources. In this case, we have validate. So it's ensuring configuration meets requirements, mutate, modifies them automatically, generate, creates the new resources, and then image verification, ensuring workloads only use like trusted, image sources. And then we have features like cleanup that automatically remove any unused or expired resources. And then background scans to check compliance across your cluster continuously, right? And then I'll show all of this in the demo as well. I know I'm just giving a quick high level overview, but in the demo, we'll get into a deep dive of all of this. We also have policy sets, and that's just like a nice way to bundle related policies for easier rollout. So this separation makes it clear on how Kyverno both enforces compliance and helps policies manage policies at scale. Yeah, so real quick, how are teams using Kyverno today? Security hardening, supply chain, multi-tenancy, most importantly, compliance as well. So it helps you with PCI DSS, HIPAA, SOC 2 when you have those strong enforcements. And then what we've been seeing as well is Kyverno integrates, most teams are using Kyverno in their CI/CD pipelines to do the policy checks way before they're even being applied, so which is critical in that shift left, security. And then also with, we can do drift detection. Kyverno is constantly monitoring your resources after admission to ensure that policy drift is not being violated as they're being deployed. A quick pause here. Any questions? I know this is most of you are aware of Kyverno, but I wanted to take a moment to see if there's any questions. Perfect. So why is this still hard? Kyverno enforces policies extremely well, but the hard part is everything around enforcement, right? So crafting nuanced policies in YAML takes skill and time. I know it's easy, but it still involves a bit of skill, right? When a policy violation does happen, explanations need to be very clear enough for different teams to act without that back and forth that we typically see. And then this, with large multi-cluster setups, this exponentially gets more difficult, right? So like remediating issues quickly across environments is a big challenge when you're talking about multi-cluster setups, right? And then with Drift, you can quickly undo compliance within minutes or seconds. And you want to detect that early enough without disruption. And then we want to incorporate governance, and so it has to fit in that GitHub CI/CD workflow without slowing releases. Or as you know, if we do that, teams will find ways to bypass it. So the key here is that we're not looking to accelerate. We're looking to ways to accelerate the entire policy lifecycle, from writing to explaining to fixing, while keeping Kyverno as that enforcement engine. And that's where agentic AI comes in. Agentic AI brings that autonomous, context aware behavior to cloud native environments. So instead of manually crafting every Kyverno policy, you describe your intent and the agent generates it for you in that right YAML format, ready to be enforced. So when a violation does happen, instead of engineers digging through all those logs, you can just ask the agent to explain rejections in plain text, and and even produce a compliant manifest to fix that issue. So that same intelligence can also watch for drift and propose or apply fixes before production is ever affected. So it's not about replacing Kyverno here. It's about accelerating that entire policy lifecycle while keeping Kyverno as that enforcement engine. I know all of this sounds, agentic AI sounds amazing, but how do we actually run it in Kubernetes? And that's where Kagent comes in, right? Kagent, again, is also a CNCF sandbox project, or it's a CNCF project, but a sandbox project designed for creating Kubernetes native AI agents. So instead of ad hoc prompting, Kagent uses Model Context Protocol, or MCP, to define tasks declaratively. That means every AI action is reproducible, reviewable, and version controlled. With Kagent, an agent can actually inspect your cluster, and we'll go in the demo as well, understand your Kyverno policies, generate new ones from just your intent, and explain why something failed, and even propose or apply compliant fixes. So it works with multiple LLMs, whether you're cloud-based or on-prem. And because it's Kubernetes native, it fits alongside your existing GitOps and automation workflows. I know I spoke a lot here. I just wanted to take another quick pause before I go into the architecture, high level architecture.
It doesn't look like there's a lot of questions. It looks more like people are very excited to see Kate.
Perfect. I'm here to
This is
show you all
perfect
of
time to
this.
jump in.
Okay, cool. Let me go into the architecture. Again, this is just a high level architecture. Shreyas is going to do the deep dive into all the inner workings and actually go into some of the code of the MCP server. So this is just a high level so you can all understand how the demo and the flow currently works. So everything starts with the user. Oh, whoops. So everything starts off with the user intent. For example, here my intent could be ensure all signed images from trusted registries are used. So this intent is passed to the agentic AI, in this case, K-agent, with very specific agent instructions, which we'll go through as well. This layer intercepts the right tools and calls the appropriate MCP tool. And this way it is declarative, structured, and makes it reproducible. And it's also version controlled, right? So those MCP instructions flow into the Nirmata Kyverno MCP server. Think of it as like a translator. It takes that AI generated instructions and turns it into actionable policy as code. Again, this is in Git as well, so it's reviewable. And then from there, it goes to Kyverno, which enforces or audits these rules right at the API server admission level. And then it persists into etcd, and then it propagates towards your nodes, scheduled throughout your nodes. What makes this powerful, just looking at this architecture, is the feedback loop, right? Kyverno is continuously scanning your workloads in the background and produces the policy reports so that you can always know that you're in a compliant state. And if we integrate this with GitOps, any drift can also be detected automatically. So this is a high-level overview. Shreyas will do the deep dive, so just wanted to set the context here. Okay, so let's go into the fun stuff now and go into the demo. Okay, so just a quick second. Um, what I wanted to do first is walk you through the configuration, right? I wanted to take a moment to actually show you how all of this plugs into, connects together and how, and then from there we can go into running some of the live queries. So I do have a GitHub repo here that I've pushed everything to, and there are a couple of files. So let me take a moment to look into some of these files, right? So the first thing is it's the tool, like the tool server. So let's like what I when I think of the tool server, think of it as like the registration desk for all the tools in your MCP ecosystem, right? The files declare like the Kyverno MCP tool as like an agent, and it describes what tools and where it can be reached. So you can see the description, just like a human readable context of, in this case, we're saying it's a Kyverno MCP tool for scanning. And then we have an endpoint for communication. So this is where Kagent knows where, how to communicate to your cluster. And then it's all deployed to the Kagent namespace. So it's all scoped within the other agentic tools. So the tool server is like the glue that lets MCP framework know, like, hey, there's a tool for Kyverno policy work. Here's how you call it. So without this, the agent wouldn't even know where to send the request. You're setting the sort of here's how you communicate with the Kyverno MCP server. Then we have the Kyverno MCP YAML. So if the tool server is the registration desk, the MCP deployment is actually, like, I would say, the workshop where work gets done. Here you can see that I have a service account and RBAC. In this case, you can when you're doing the policy scans, you want to give it some access to scan. In production, you can lock this down. In this case, I'm giving it read access for my cluster. Then from there, we have the RBAC rules and the service account. So this is where I'm telling Kyverno what image to use and how to expose the port. In this case, it's 8080. I'm also mounting the kube config for remote in case, because our MCP server can talk to remote clusters as well. So I'm giving the cluster awareness, the MCP server awareness of, hey, there's multiple clusters. Again, if you're running in production in the same context, you don't need to mount your kube config, so you don't need to deal with all the secrets. And then we have the service account here, where this service makes the MCP discoverable inside your cluster so that the tool definition that we show can actually connect to it. So this is, at a high level, the Kyverno MCP YAML file. And then we have the agent. So actually, let me go into the instruction and the agent. So the agent is where we put in the intelligence, right? This is where your intelligence is described, and the Kyverno and the tools that we do, it gives the instructions on how you want your result set to be produced, right? So you define the skill set. In this case, I'm giving it multiple skills, like I'm asking it to generate, explain, recommend, debug, and support. And then from there, it gives me, I give it very detailed instructions of how to understand the policies, how the syntax should look, the best practices to follow, and some complex use cases, and then give it assumptions. So you'll see in the demo as I run these queries, how I'm getting the structure. So it's important to have very good instructions for your agents. And then from there, you can get the repeatable answers that you're looking for. So, how does this like sort of tie into with MCP? So these instructions map natural language intent into structured MCP requests. The actual cluster actions via the tools that we've exposed the agent to, it bridges that together in a human-friendly request, which is machine enforceable policies. So that's how you can tie your agent instructions to the Kyverno or all the other tools or agents that we're configuring our agent to do with.
I'm going to
Yeah,
ask
sorry,
you to pause for 1 second, Mayur,
Yeah.
to see if you might be able to zoom in on your screen just a bit for some of
Oh,
my.
yeah, sure. Is that better?
I think that's probably better.
Okay, thank you.
Ronald Petty, let us know if that's better.
And if there's anything else I want to look into, please let me know. And
We
then
can
last,
take a moment. There are a couple of questions, and
yes,
I think let me see here. There are a couple of questions about where this is hosted. I'm going to share it on the screen. Is Kyverno and Kagent hosted in GitHub? They've read this could set off alarms for data sovereignty. I haven't heard this, but have either one of you heard anything about this?
I have not. It is in GitHub. Like, these are all open source. Kyverno and Kagent are both open source projects, but I have not heard anything about data sovereignty. Again, with data sovereignty, it's best practices to not, put sensitive information to these agents. But again, that's up to different rules in different countries and their sovereignty rules.
Great. We've got a couple of other questions that are mostly about if we're going to be giving the URL at the end of the session. We promise we will. And also for anyone who just joined, we'll definitely have a recording of this living on the CNCF YouTube page. We've got one more question. We'll go ahead and pop it up here on the screen. Is the MCP server installed in the same K8s cluster where we want to implement the policies through Kyverno?
Yes. It is, and I'll let Shreyas as well do a deep dive. But it is installed in the same K8 cluster. But we have given it. Shreyas, do you want to expand on it in terms of some of the remote use cases and changing clusters?
Sure. Yeah, actually. So the MCP server can be run on the same K8 cluster, or it can be run on the host, right? So it doesn't matter on the environment, but just to keep in mind that if you're running it on the host, then you can do multi-cluster, uh, policy implementations. But if you want it to be in a specific cluster, then you deploy it only in one single cluster, and there's no multi-cluster environment as such. So that's just something to keep in mind. But yes, you can definitely have it in either on the host or the same K8 cluster.
Great.
Thanks, Shreyas.
Thanks for the question and thanks for the answer. And Pangja, stick with us because we'll see a demo of this in a little bit that will give you an explanation of the architecture.
Yeah, demo in literally a minute. So
Go for it, Mayur.
yeah, so I just wanted to talk about the Kyverno agent. This is what we'll see in a second. This I would recommend. This is generated for you. I use the K agent, creating agent UI to create this. And this the key thing is it gives you the tools that you want your agent to be exposed to. Cool. So let's go into the demo now. I know a lot of you are looking forward to that. So here's the K agent dashboard. This is where all your different agents are. Just to give you some context, this environment, this demo is on my local Kagent cluster. It's configured with, as you can see, OpenAI, and it's running locally to my computer. So just an overview of where this is running. I know there were some questions about that as well. So I have already pre-created all of this agents with the MCP integration that I just showed in GitHub. So let's go ahead and run some queries here, right? So let me go ahead and show you some basic queries. So the first thing I want to do is I want to make sure that Kagent can talk to my cluster, right? So let me ask again.
Can you
Should I
zoom in one more time?
Yes.
Mayur is zoomed back out.
All right, is that better?
Before you get started, because this is the part everyone wants to see.
Okay, can you see, is this better?
I think that's probably better. What's going to come on your screen will be bigger also.
Yeah,
If it's
okay.
better, folks, please let us know in the chat.
Okay, cool. How many? So the first thing I want to do is make sure that K agent can talk to my cluster. So again, with plain English, I'm asking how many namespaces do I have. So let's see what we get. So again, this is just using the K8's tool here that I've configured, and let's see what happens. So it's calling the K8's get resources, and it's complete. So and there we go. I can see that I have 8 different namespaces here. So K agent is able to talk to my cluster. I'm just gonna copy and paste on these queries are pre-populated because I don't want you to see me type. And so let me ask it like how many pods are running the K agent names. Again, this is just more of a sanity check to see if we're able to talk to a cluster with K agent. Again, it's calling the K8's resource, and boom, it tells me that 21 pods currently running. So now we know that K agent is successfully talking to my cluster. So now let's go into the governance side of things, right? So now I want to start off with an intent here. So picture me being a platform engineer, and I want, I want to know what, pods are running without a team label assigned. So again, I'm giving my intent here. I want to know and audit every pod that does not have a team label, and that's my intent in plain English. And let's see what happens, right? So I know since it's zoomed in, I have to scroll. So give it a second. And yeah, so I know a lot happened. Courtney, can you see this well, or is the zoom level okay?
I think it's much better now than before. So yes.
Okay, perfect. So here you can see, because of the agent instructions, how I asked it to generate, it generated me the policy that I was looking for. You can see it's an audit. I asked it in the background. So audit means that you will still deploy, it won't enforce it, but it'll know if a violation happens, it'll let me know. It's running in the background and it's giving me all that I asked for, like a clear YAML with the intent I asked. Gives me a detailed explanation as well, and also tells me if violations happen, it'll be visible in the policy reports, and gives you some assumptions, some alternatives. As I mentioned, it's also telling you if you don't want people to deploy, you can just use the enforce instead of audit, and gives you some limitations. So this is with one intent, I'm able to get everything I'm looking for without the struggle of figuring out what the policy YAML is, what are the alternatives, what are the limitations, right? So it's very amazing in terms of just intent. I'm able to get the governance policy I'm looking for. So let's go ahead and deploy it. So it's asking me if I want to deploy this. So I just said, yes, deploy this policy. I know there may be questions on deployments and access. For this demo, I have given access to do deployments. What you can do is integrate this. There is a GitHub MCP server integration, so there could be a human loop as well. For the demo, I've given deployment access, but you can tie down how your access is depending on your use cases. So there is GitOps integration with other MCP tools like GitHub that you can use. So it's going ahead and deploying this policy for me. And let's see what happens. Okay, so I have a existing. So let me just, sorry, whoops, zoom in. So what I'll do is, let me just put this in a new tab because I already have an existing pod here. So I'll just do it through here. So I want to deploy and audit every pod. And just let's do it through a new tab because I do have an existing thing, so it's denying it. So let me just go ahead and say deploy this policy. Deploy this policy. Okay, cool. So what just happened here, because I had run some tests, it got a bit confused. So I just put in a new chat and reran it, and it deployed. So let's just check. If what Kyverno policies are deployed. Kyverno policies. Sorry, policies are deployed. And you can see this policy is now deployed. So perfect. Now, the next thing I want to do, so we've got our intent, we've deployed the policy. So now I'm an engineer, and let me go ahead and violate this policy, right? So I'm asking to deploy a simple pod with no team label in the default namespace. Again, the policy I deployed was making sure that we're auditing every pod that's deployed has to have a team label enforced, right? So again, it's deploy this pod. Let's make sure that this pod is deployed. So I'm just asking it, what pods are running in the default namespace? So it says it's deployed. This, I want to make sure that it's deployed and it's calling the right tool. And it's taking a second. And let's just do this. And you can see that the team test pod team label has been deployed. Perfect. So we have violated the rule, the policy that I just created. So let's go ahead and actually see, like, let me run the show violations tool that's available with the Kyverno MCP server and see what we get. So again, I have no idea. I'm just running this with my intent to show me violations. And then you can see there is one violation, and it's telling me there's a pod here that does not have a team label, and it's failed. And it's actually giving me a policy. In fact, I can ask it to go ahead and fix the policy, the pod that I deployed to fix it. So it's giving me what the policy issue is, and gives me an action item if I do want to resolve it. So it's very cool. Just with my intent, I can get exactly the reason and also a follow-up on how I want to resolve this. So that's showing you violations. If you have multiple environments, you can see how quick you can scan through all your different namespaces just with showing violations tool, right? The other thing I wanted to show you was, I talked about this quickly in my presentation, but I wanted to show you the policy set. So this is where we've combined, in this case, default policy sets or default best practices. And I want to scan the default namespace with these policy sets that I've already defined. Trace is going to do a deep dive on how this tool works, but I wanted to show you in action how this actually works. So what's going to happen here, it's calling the apply policies tool. And then once it calls the tool, so it takes a second to generate the UI response. And there you can see here, it scanned it, and you can see that simple pod that I just deployed has violated a lot of these different policy sets. For example, running as root, default namespace, you don't want to deploy there. I'm using, Nginx latest, for example. So you can see just with me using our tool, I ran it with the policy set and I'm getting a quick summary of everything. In fact, if you go here, it can even tells me here if you want, I can help you address this and generate those policies to match your requirements. So again, with my intent, give me the results and also follow up in terms of how I want to resolve this. So I have a couple more things I wanted to showcase to you as well. Is I wanted to showcase a complex query, right? Like, what if you wanted to run more of a complex YAML enforcement other than simple team label enforcement? For example, here, I want my intent here is that I want to verify that container images used come from a trusted registry and are signed in this registry while enforcing security best practices on supply chain related workloads. So this is a complex Kyverno policy. So let's see what happens if I ask the agent here with my intent to see what happens. So just a second. Cool. So call the agent, gave me the policy, and again, as we just saw with the team label, gives me a clear explanation. So here you can see that it gives me the resources, the image registry, even gives me a placeholder on where I want to put my public key, and gives me a clear explanation of how this works, any alternatives. For example, it's giving me a suggestion here to audit, and then gives me some limitations. So this is more of a complex use case, and we're able to simply get it to a point where we're able to 90, like I think of it as Copilot in some of these complex cases, gets you to 95% of where you want to get. And in this case, all you have to do is put in your public key and then deploy it, right? And also, last thing I wanted to show you is that we do have a helper tool as well, a help tool. So you can actually, this has aware of all the Kyverno docs. So I can just ask it like, hey, you're using a mutation here. What is the mutate policy? Use the help tool, right? So it's going to reference our Kyverno docs. So you don't have to dig through that. And it'll give me, immediately from there what the mutate policy does and gives you some examples and tells you how to use it. So, any questions here? I know I've covered a lot of amazing things, but any questions here? I know.
We've covered a lot of stuff. We do have a handful of questions that I think would probably be great. Starting off with this question from Alexander: which model is Kagent based on by default? Since we are using Kagent for this demo, do you happen to know which?
Yeah. I'm not
which
sure if
model?
they've updated it, but when I initially installed it, the initial installation, again, the documentation is getting updated regularly, was OpenAI, but it's you choose your agent and you can configure it. I used OpenAI, but they're adding a lot of support every day. So I think default is OpenAI, but you can change it anytime.
Great. And I'm sure Shreyas is going to address, but this Kyverno MCP server can be used with a lot of different tools, right? Not just Kagent.
Yeah, absolutely. So sorry, the question was having the MCP server be used with other clients or other tools, not just Kagent.
Not just Kagent, right? We can
Yeah.
use it with all the tools that are out there.
Absolutely. So I will explain during the deep dive on what our MCP server is capable and where we can use the MCP server. Really, you will see it in the upcoming slides.
Yeah.
Okay. We've got a couple of other questions here. Ludovic is asking, in this example, will it be accurate with running pods?
Yes, I'm not sure exactly what you mean by running pods, but yes, K-Agent can talk to running pods and can, I know what you're asking. Yeah, in terms of background scanning, if there's already existing pods, because I have the background label as true, it's able to pick up existing running pods as well as violations.
Great.
Great question, by the way.
Also surprised that Kyverno isn't just applying admission control, and very thankful to Ritesh in the chat who gave some insight that it also has background capabilities too. I think it's probably a surprise to quite a few people. So thanks for mentioning that. I saw a couple of other questions down here. This is a good one. Always talking about security. I see you're using an API-based model. Is that not risky in matters of infrastructure security? And could it be better use of local models to avoid data leaks? He has been insisting on this in the chat, but I think it's a very, very good point to insist on.
Yeah, great question, and that is true, right? Like whenever you're using any of these LLMs, security is a big concern, and yes, local models are recommended as well. I mean, also following best practices when you're using these agents, right? But I agree, local models is the best way to solve data leaks.
Absolutely. Here's a great one also. We'll have two more and then we'll move on because we're just about at the halfway point. But Ronald's asking, is there a way to undo things, meaning the policy is removed versus maybe a partial removal of a policy?
Yeah, great question, Ronald. You can, with your intent, ask things to remove policies. You can actually ask it to edit some of the policies with natural language. So, if, for example, one of the questions here I asked it to do was an audit policy, right? I can ask the agent, hey, I want this to be enforced, and it can proactively edit the policy as well. You can undo it in the sense where you can ask it to delete or remove that policy as well. So you have whatever you're currently using in kubectl CLI, you can run it with just intent.
Great. And final question for this part. Adonis asked, and there is some chatter about it in the chat, but would deploying the policies this way work on multi-cluster setups? What do you think are the best practices for multi-cluster setups in this case?
Yeah, I'll let Shreyas expand on that because I know there's some tools that we have that can do multi-cluster. Shreyas, do you want to talk about this now, or you want me to wrap up my demo and you can explain it during your section?
I can quickly answer it and then maybe expand on it during my
Okay, sounds good.
slide. Yeah, so to quickly answer that, yes, you can definitely work on multi-cluster setup, especially if you have the MCP server running on the host and not on a cluster itself. So that way, it basically has access to multiple clusters, accessed via your kubeconfig file. And we'll talk about it more as we get into the other slides.
Great. We're looking forward to the next step. I'll pass it off back to the both of you to keep going.
Yeah, I'm just going to recap real quick on what we saw, and then I'll pass it off to Shreyas. So what we just saw is how like Agentic AI through Kagent and Kyverno MCP server can actually take your natural language intent and translate that directly into Kubernetes policy actions. So the big takeaway here is that instead of manually writing your YAML or combing through violations or writing GitOps pipelines, we're able to describe what we want in plain English. The agent interprets that, generates the MCP instructions, then Kyverno enforces them at the cluster level. So this, most importantly, shortens the feedback loop, reduces that human error, and makes policy enforcements both scalable and approachable. And yeah, that's my side of the demo. Thank you so much. And back to you, Shreyas.
Awesome. Thanks, Meyer. Let me share my screen real quick. Let's get started. All right. I hope this is visible to all of you. Just to confirm, Courtney, can you see my screen?
Yep, we can see your screen.
Perfect. All right. So let's get started. So we've been talking a lot about MCP, but what exactly does MCP stand for, and what does it really translate to? So MCP stands for Model Context Protocol, right? And before MCP existed, your AI assistant was as good as a chatbot, and that is all it would be limited to. If you asked, let's say, ChatGPT for the weather tomorrow, it would say my cutoff date is so and so, and it would fumble completely. But with the help of MCP now, what we can do is now enable these AI chatbots or assistants with multiple tools. So we're enabling these chatbots to actually act upon a request. And in this case, in this specific scenario, we have a Kyverno MCP server, and we run Kyverno commands and control Kubernetes clusters through our MCP server. So moving on, the tools that we currently expose via the Kyverno MCP server are 5 in total. And the major two are apply policies and show violations, right? So the reason I say these are the two main tools is because the apply policies basically takes any of your policies, whether it is in a Git repo, whether it is stored locally, or if you're in an air gapped environment, you don't even have to provide your own policies because we actually provide default policy sets just via Kyverno, and you'll see how we do that in the code in just a minute. So the apply policies can actually take any of your policies and test it against a live cluster to see real time violations, right? So let's say you just deployed a pod, you don't know if it's actually uh, you know if it actually violates a policy or not. You can try applying your policy to see if your resources or that pod actually passes or fails accordingly. Similarly, the show violations is there to show any pre-existing violations. So someone already asked this question about does it work well with running resources, running pods or running deployments, right? The show violations tool is meant specifically for that. So let's say you've actually already you've applied some policies to your cluster, you have deployed resources, and there are some violations, right? But you don't want to look at the policy report and dig through it to really understand why it's failing or what kind of violations there are. So the show violations tool makes it a lot more easier to just find any pre-existing violations and spits it out to you in a much neater natural language. So the three other tools that we have are list context, switch context, and help. So list context is used especially when you want a multi-cluster setup, right? So when you're running the MCP server on the host and not a, uh, a Kubernetes cluster, you can list the clusters you have access to via the kubeconfig file. And then the AI assistant can actually figure out what cluster you're talking about. For example, if you have an EKS cluster, you can just say, look at my EKS cluster and show me violations. So then it actually lists the context from your kubeconfig file and makes sure that your EKS cluster is actually the name that you provided and not the ARN, right? So it's smart enough to decide what the actual name of the mentioned cluster is. And finally, once it verifies the name of the cluster that you want to talk to, it uses the switch context tool to switch to that specific cluster and then operate on it. Right. So these two tools are very important when you're trying to do multi-cluster operations or anything to do with multi-cluster whatsoever. And then finally, the help tool. So the help tool is there in place to also assist you during an air gapped environment. So that way you don't have to go to the Kyverno documentation online and look things up. The chatbot in this example, if Kagent was deployed on a cluster in an air gapped environment, it basically can just use the help tool to get some very quick troubleshooting and installation docs, as that's that's two documentations we found extremely important and useful when trying to debug any failures or anything that's related to installation. Right. So those are the five tools that we currently have. Let me switch over to the code to show you exactly how we've implemented this. So not to spend too much time on each tool, I will only talk about apply policies and show violations. So let's quickly dive into the apply policies tool and see how things are going. Hopefully you can read my screen well. Hmm.
Great question. If somebody can't read Shriya's screen well enough, please let us know in the chat and we'll try to zoom in a bit.
Cool. Okay. I don't see anyone complaining, so I'll continue. Uh, cool. Okay. So this right here is the apply policies tool. And what we have here is the three default policy sets that we offer also via Kyverno, right? So we just took concepts from Kyverno and put it in the MCP format is all we've done here. So the pod security policies, the RBAC best practices, and Kubernetes best practices are all offered through the MCP server by default. Uh, no additional installation required whatsoever, right? So let me scroll down and show you where the meat is, right? So this right here is where we're actually creating the tool, right? So if you see, we're creating a new tool and then we're providing a description. So how does Kagent know when to use this tool? Have you ever wondered that? I've always, wondered, like, if I've just added an MCP server to my cursor or whatever setup, how does it know when to call that exact specific tool, right? And that's done through the description. So the assistant actually has access to the description and says, "Oh, okay, that matches exactly what the user is asking me to. Let me pull that and let me call that specific tool." And the best part is the parameters and the arguments that are taken by the apply policies tool are also fed to the AI assistant. That way it knows exactly what needs to be given to the apply policies tool and then calls that, right? So this is where the magic happens, and there's some backend code to basically say the policy sets, the provided policy sets is not all, or if it is all, then we provide everything that we already have by default, and so on and so forth, right? So if you want to exclude certain namespaces, like for example, Cube System and Kyverno are the namespaces that we completely ignore because we don't really care about those. We want to see the namespaces that we have really created and deployed policies or resources onto, right? So we've excluded that, and then yeah, excuse me. So that's basically all the backend code for the apply policies tool. Now, if we go back and look at show violations, so the show violations tool is a little bit tricky. So during our alpha testing, we realized that what happens is the policy reports are huge. They're really big, and sometimes that actually exceeds the context window of the LLM itself, and that causes an error. So the LLM basically says, "Oh, that's too long. I'm not going to read it." And then the AI assistant completely fumbles and says, "Oh, it doesn't return anything. I'm sorry." So we actually had to write extra code to retrieve not just the policy report, but also put it in a neat little format that we can then provide within the context window limit. Sure. Now there are AI models with 1 million context windows, 1 million token context windows, but not all of them have that. They're only, you can count them on your fingers, right? So now what we can actually do is basically take the policy report that's already existing on your cluster and put it in this nice little format, feed it back to the AI assistant, and then provide it as a result of the tool, right? So that is literally all we're doing here, and yeah, so similarly, just like we created the new tool for apply policies, we're doing that for show violations as well. The same description, I mean, not the same description, but also a description with two parameters that we're accepting, right? Namespace and namespace exclude. So that's basically how we've implemented both of these tools. And I would love to go into the other tools, but I don't think they're as important. And this is completely open source. So if you want to dive into this, if you want to look into the code and try things out yourself, please feel free. And we're also actively looking for contributions, right? So at the end of this presentation, you will see resources to access this as well. So, yep. So that's about the GitHub repo. That's about the code. Let me go back to our slide deck. All right. So coming back, let's try and piece our uh, parts together. So we've seen different parts of it, but how did they really come together to form the puzzle, right? So let me take you through the workflow. If this is too much text, forgive me, but I'll do my best to break this down and explain it as best as I can. So first off, we start off with a user prompt or an intent, as we call it, and that is basically fed to an MCP host. And here, someone already asked us, right? So does it have to always run in a KH environment, or can we run it anywhere else, or does it always have to be KH, right? The answer is no. You can run it anywhere and everywhere you want it, or at least in the supported ones. And a lot of tools currently support it. For example, Claude, right? Obviously because Anthropic also created the MCP, the Model Context Protocol themselves. So Claude also supports MCP out of the box. So you can configure it all you want, add a bunch of MCP servers to it. Cursor is another one, which is a very famous vibe coding AIDE, right? You can also add this MCP server to the cursor and start just talking to it in the agent chat box. Similarly, there's Amazon Q. I think that's a little less known than the others, but Amazon Q is supposed to be a CLI that you can use, something similar to Cloud Code, but Amazon's version of it. And then, yeah, of course, Kagent, something we've already seen from Meyer. So those are the hosts that I currently have here, and you can use to basically link the MCP server with. So coming back to how the MCP client works, right? So every host that we have also ships with a client. And what that means is because we have a server, we need to have a client, right? And that's where the client really exists or lives within your host. So then the client basically takes these parameters, these tools, tool names, these arguments, and then feeds it to the MCP server. Now you may be asking, how does the intent go to the structured format? Now that's where the intelligence comes in, right? The LLM is smart enough to decide by looking at the prompt and looking at the description of the tools provided by the MCP server. All right, so this is the tool that we can call, and here are the arguments, and it extracts certain values from the user intent and plugs it into the tool call. For example, here it's dev test 2, but it can be test or dev test 2, you name it, right? And then it's fed into the MCP server, and then the MCP server, uh, or rather, the MCP server calls the tool, right? And I oversimplified it by saying it's a very simple kubectl get polar slash n test, but in reality, you saw in the GitHub repo that it's a lot of backing code to simplify that result that this spits out right here, right? So there's a lot more that goes on from this command. And finally, that's fed back to the MCP server and then says, okay, I ran this tool, and here's the tool call, here's the result. And that's fed back into the MCP host, and then the LLM in that host, for example, cursor, looks at the result from the MCP server and says, okay, so here's the result. And it basically augments it, takes that as additional context, and says, so here's what I got back with, and here's what you can do next. And it even asks sometimes, do you want me to do this? Do you think this is the right next step? Right. So assistants are also getting better at sort of asking the end user for input or feedback on what they should do next, or what they think is the right next step, right? And that's how the workflow really is. That's how the cycle completes. All right, so that's the end of the MCP demo. I hope that was quite informative. I know I spoke a lot, but if you have any questions, please feel free to ask me any of them. And here are the links, the QR code. You can scan them and go to them directly. This is the Kagent's community QR. This is the Kyverno community QR, and this is the Kyverno MCP GitHub repo QR. So, yep. All right. Thank you, everyone. Please ask me if you have any other questions.
Awesome job, both of you. We'll give everybody just a couple of minutes to see if there are any questions, since we still have a couple of minutes to go. I've shared there the repo link, the direct repo link to all of the resources that have been used today. There's also the resource page. Thanks for putting that back up there, Shreyas. I'm sure there are a lot of people who are interested in this. Let's see if we've got any questions coming in the chat. Oh, thanks so much. Let's see, you guys did a great job. Everybody's very excited about this stuff. Here's a great question that just rolled in. So we'll pop it up here on the screen. If a critical agent like Fluidbit or EBS CSI driver fails on some nodes, how can you combine these generative tools and alerts with what we saw here today? Is there any way to do that?
Stress.
That's a good question. I'm not very familiar with Fluidbit or EBS CSI. Um, yeah, I'm sorry. I actually don't know. I haven't dealt with this before. So
That's okay. Also, we're diving into a whole new world, right? Prometheus alerts plus agentic AI, and how are people going to manage those things? There's a lot in that question. This is a great question, Hermant. If you'd like to continue that conversation, we've got an entire team of maintainers for our Kyverno project that I'm sure would love to bounce some ideas off of the wall with you. Let's see. Heath says it was a great session. Ronald, who's been with us this entire time, has a question. Let's see what he says. Any look at KHGPT? as a possible integration with Kyverno and our Agentic AI?
I think so. I've been spending a lot more time on Kubectl AI by Google, and I've sort of like moved away from KHGPT and more into Kubectl AI for deploying and basically doing stuff on the clusters, not just on the observability part, which is what KHGPT I think focuses more on. But yeah, I'm more familiar with Kubectl AI, and yeah, I mean, if KSGPT ever comes up with an MCP server, yeah, absolutely. So the best part about MCP server, like I explained earlier, is you can plug and play wherever you want it. So if you're creating a cube, uh, a K agent, customized K agent yourself, you can integrate your own KSGPT with that K agent, that specific K agent that you build, and it should work just fine. So it's no problem whatsoever.
Absolutely. And I think one of the biggest things here to call out, Ronald's probably not the only person who's interested in this. And that is the power of community, right? The more people who speak up and show interest or support this idea, the faster things will get done. Oh, here we go. He says they did an MCP integration a couple of weeks ago. The docs need some help. Docs always need help. There are people out there listening and you're looking to make your first contribution to open source, definitely join in, because docs, as Ronald has drawn attention to, always need help. This is a fantastic session, guys. We're coming right up on time. So thank you, everyone who has joined us here today. You have that resource slide still up there for the next moment or so. Please remember that this session, as well as all other Cloud Native Live sessions, live inevitably on the CNCF YouTube channel. You guys have been great. Fantastic questions. Please be active in the Kyverno community, the Kagent community. And also, if you'd like to contribute to Nirmata MCP server and community, please reach out and do so. Absolutely great. Thank you both, Shreyas and Mayur, for joining us today. And we'll see everyone again soon.
Thank you, Courtney. Thanks, everyone.
Thanks, Courtney. Thank you for having us.
Bye-bye.